Good morning students, welcome to the class. Dear students, in today's session we are just gonna to discuss the basic concept of the complex number. Okay, if you are just thinking to appear for the test of NDA, okay, then this topic is quite important. So in today's sessions we are just gonna to discuss the concept and some kind of questions along with the concepts so that you can better understood the things related to the complex number. At first, I would like to discuss with all of you that what is complex number. Complex number, actually when we are talking about the numbers, we have been thinking about different kind of numbers. We have been thinking about real numbers. We have been thinking about rational, irrational numbers, negative numbers, positive numbers, whole numbers, natural numbers. Okay, so I would love to tell you that if you are thinking about any sort of the number, any kind of number, that is really complex number. Okay, I mean to say complex number is just the combination of two different kind of numbers. These are one number will be real number and another will be imaginary number. So always remember this, that the complex number is a combination of two kinds of number. One is real number and another is the imaginary number. Okay, one is real number and another is the imaginary number. Now we will discuss what is real number and what is an imaginary number. Okay, I just want to tell you, I'm just writing here a few kind of numbers and you can tell me that which number is the real and which number is the imaginary. Okay, listen to me, every kind of number is a real number except if there is a negative number placed inside root, that is imaginary number. Understand that? Okay, all numbers are real number. I am saying 3, this is integer, it's a real number. 0 is also real number. Root 3 is also real number. Minus 5 is also a real number. 2.5 is also a real number. 1/2 is also a real number. I mean to say any kind of number you are thinking within your brain, that is real number. But if you are going to place a negative number inside the root, okay, inside the symbol of surd, this symbol is known as surd, and if you are going to place a negative number inside this, -1, this is imaginary. Under root -5, this is imaginary. Under root -6, this is imaginary. So all these kind of numbers are the imaginary ones, and all these numbers are the real numbers. So always remember that every kind of number honestly is a complex number. Okay, because whether it is real number, it may be only imaginary number, or it may be the combination of both real and imaginary. Okay, so always remember that what is complex number. Complex number is nothing, it is the combination of real and imaginary, both kind of numbers. Now we will discuss the existence of the imaginary numbers, how these numbers were existed. Okay, so we are just gonna to discuss this. I'm just gonna to write a equation, a small kind of equation in front all of you, then we will discuss about this. Suppose I'm writing over here that x square plus 1 equal to 0, and I'm going to calculate value of x. Okay, this is a quadratic equation, and what we have studied in our previous classes before 10th, we have studied that there will be a value of x which is just going to justify this equation. Okay, but you will see that there is not any kind of real value which can justify this equation. So there is no real value which can justify this. We are just going to talk about the imaginary numbers right here. So I can say, students, over here that x square will be equal to -1 and x will be the value of plus minus under root of -1. So you can see the x is just giving two different kind of values. One is plus under root of -1 and next is minus under root of -1. So this value is known as the basic form of the imaginary numbers. Understand that? Okay, now under root -1 is denoted by a specific symbol. Okay, we can say that under root -1 will always be equal to this I, and this I is known as iota. Okay, we call it iota. Understand that? So iota is always equal to under root -1. Now this is the basic unit of the imaginary numbers. This iota is the basic unit of the imaginary numbers. Now we are just going to discuss few basic values related to the iota. Okay, now I think you would have understood all the things related to the complex number and the imaginary number so far. Now we will discuss some basic units related to this basic unit of the imaginary numbers, means iota. Okay, so as we have discussed that iota is equal to under root minus 1. Now just to simplify our questions, okay, we should know that what will be the value of iota square. So always remember iota square will be equal to square of this, so it will be equal to minus 1. Now I'm going to calculate value of iota cube. Iota cube can be written as iota square multiply iota, and value of iota square equal to minus 1, and it can be written as minus 1 into iota, so it will be equal to minus iota. Understand that it will be equal to minus iota. Now we need to know about iota to the power 4. So I can say iota square whole square, and it will be equal to minus 1 whole square. It is equal to 1. So what did we do over here? We just discussed the 4 terms related to the iota with the consecutive powers starting right from 1. So iota to the power 1 equal to under root minus 1, iota square equal to minus 1, iota cube equal to minus iota, and iota to the power 4 equal to 1. These are the basic values you should always remember. Okay, now these 4 terms are quite important just to enter in this topic. Okay, many times when you will be solving the questions related to the complex number, you will be directed by the examiner to calculate any term related to the iota having power greater than 4. Suppose you are said to calculate that, just get the value of iota to the power 1067. Okay, we have to calculate iota to the power 1067. So how can we calculate this particular value iota to the power 1067? It is quite easy. Firstly, as I told you that we should know the values right from iota to the power 1 up to iota to the power 4, iota to the power 1, 2, iota to the power 3, and iota to the power 4. If you are getting any term of the iota having power greater than 4, what you have to do? Just divide the last 2 digits of the power with 4 and get the remainder. Okay, firstly you have to get the remainder. Okay, just dividing the last 2 digits of the power by 4. So I am going to divide last 2 digits of this number by 4, and I am dividing 67 by 4, and the remainder will be 3 over here. Okay, now this term iota to the power 1067 will be equal to directly iota cube, and we already know the value of iota cube. Iota cube is equal to minus iota, so this is the simplest answer of this particular term. Iota to the power 1067 is equal to minus iota. So with the representation of this particular question or the example, you can understand that if power is greater than 4 and you are gonna to divide that particular power by 4, if remainder 1 you are getting, then that term will be equal to iota to the power 1. If you are getting remainder 2, it will be equal to iota square. If you are getting remainder 3, it will be equal to iota cube. If you are getting remainder 4, you can't get remainder 4, you will be getting remainder 0. Okay, if you are getting remainder 0, it will be equal to iota to the power 4, means it will be equal to 1. Understand that? So this is the very basic thing you have to keep in your mind. Now again, I'm just going to place a question in front of you. Okay, and the thing we are just going to discuss next, many times the question have been asked on that particular term. Okay, so what is the thing we are going to discuss over here? Sometime you will see this kind of question. Suppose I'm saying to calculate or simplify iota to the power 1093 factorial. Okay, this is the question, we have to calculate it. Now remember to me, remember one thing always in your mind. I'm just going to tell you, here the power is 1093 factorial. So power is obviously greater than 4, but it is represented with the factorial. Okay, so always remember, when the power is in factorial form, you don't have to apply this method that you need to divide the power by 4. Here we are not going to divide the power 4. Here is a simple kind of concept, and you have to remember that concept. Okay, I am going to tell you that if power is in factorial form and it is greater than 3 factorial, then value of that particular term will always be equal to 1. I mean to say, if anywhere you are gonna to see that I'm saying that if n greater than 3, then iota to the power, then iota to the power n factorial will always be equal to 1. Okay, n is greater than 3, then iota to the power n factorial will always be equal to 1. So this is a quite simple kind of concept. I mean to say, you are getting a term of iota with power greater than 3 factorial. In that case, you don't have to divide the power with 4. Its value will be directly equal to 1. Okay, but it will be applicable when the power is greater than 3 factorial. And I have a question for all of you, just based on this particular concept, and the question says that we have to simplify this, and this is a previous year question and it has been asked in NDA examination. So question says that we have to get the value of iota to the power 1 factorial plus iota to the power 2 factorial plus iota to the power 3 factorial plus dash 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 iota to the power 2016 factorial. We have to calculate the value of this particular question. Now what will we do? As we discussed that each term of iota will be equal to 1 if power is greater than 3 factorial. It means in very first term the power is 1 factorial, second power is 2 factorial, in third power is 3 factorial. So we have to calculate these first 3 terms in a manual way. But after that, for each term value will be equal to 1 because next term will be iota to the power 4 factorial, so it will be equal to 1. Next term will be iota to the power 5 factorial, it will be equal to 1. Next term will be iota to the power 6 factorial, it will be equal to 1. So after iota to the power 3 factorial, each term is producing its result equal to 1. Okay, so what would I do? I will calculate the values of these first 3 terms manually. So iota to the power 1 factorial, it will be equal to iota, and this is iota to the power 2 factorial, it is iota square. And next term will become iota to the power 6. Okay, and after that each term is equal to 1. So we should know that how many terms are there from 4 factorial to 2016 factorial. So we can say that there will be 2013 terms because first 3 terms are removed, and from 1 to 2016 there will be total 2016 terms, and first 3 terms have been calculated manually, so remaining terms will be equal to 2013 because each term is just equal to 1. Okay, now iota is written as it is, and iota square minus 1, iota to the power 6 divided by power 4 because power is greater than 4, so it will again equal to iota square, and it is again minus 1 plus 2013. So answer of this particular question is iota plus 2011. This is the answer of this particular question. So far we have discussed just 2 basic concepts. Okay, now in first concept we discussed the 4 basic units of the iota: iota square, iota cube, iota to the power 4. In next we discussed that if power of iota is in factorial form and greater than 3 factorial, it will always be equal to 1. Now we will discuss few more things over here related to the complex number, or you can say imaginary numbers. Okay, dear students, I just wanted to tell you very simple kind of things. Okay, suppose you are going to get a question like calculate iota to the power 1037 plus iota to the power 1038 plus iota to the power 1039 plus iota to the power 1040. This is a kind of question, and you have to calculate this. And this is not a tough kind of question, but you know, when you are gonna to appear for NDA written test, time is most valuable thing over there. Okay, because if you are going to calculate, you are just going to get 1 minute 15 seconds for each question, whether you know the question or you don't know how to solve that question, but time is the most valuable thing over there. Okay, so each of the student can calculate this just by applying the basic thing we have discussed, that we have to divide the last 2 digits of each power by 4, and we will get the remainder, and we can simplify the question. But there is a concept that is very easy concept. If you are getting 4 terms of iota with consecutive powers, okay, here the powers are the consecutive 1037, 1038, 1039, 1040. So it will always be equal to 0. It will always be equal to 0. So always remember the concept. If there are 4 terms of iota with consecutive powers, okay, then it will always be equal to 1. This is a concept. You can note it down or write it down in your notebook. Okay. Second, I have another question over here. These are the basic kind of things. If I am saying that there is a kind of question that you have to simplify iota to the power 3097 plus iota to the power 3099. Okay. Now you can see that there are 2 terms of iota with consecutive odd powers. What kind of powers? Consecutive odd powers. So sum of these 2 terms will be equal to 0. So another concept developed over here. If you get it during your calculations 2 terms of iota with consecutive odd powers, the result will be 0. Third, what is the third concept? I am saying that you are just directed to calculate iota to the power 2028 plus iota to the power 2030. Now you can see that there are 2 terms of iota with consecutive even powers. So sum of these 2 terms will equal to 0. Sum of these terms will be equal to 0. So you just have to remember 3 kind of things. Number 1, if there are 4 terms of iota but the powers are consecutive, it will be equal to 0. If there are 2 terms of iota but powers are consecutive odd, it will be equal to 0. If there are 2 terms of iota but the powers are consecutive even, then sum will be equal to 0. And you know, based on this simple concept, many good kind of questions have been discussed in your NDA question paper. Okay, we will discuss the questions. Okay, but I'm just writing a question over here and you have to think on this question. Okay, and I will provide you the solution in next session based on this question, because in this particular session we are just gonna to discuss the most of the formulas and the concepts, okay, related to the complex number. The question is that you have to simplify this summation you have to calculate the value of this, and to simplify this particular question you have to apply the concept we discussed recently just before this question. Okay, now I'm just gonna to tell you a few more things over here. You know, many times we will get to solve that what is the value of 1 plus iota whole square. We have to simplify this, and always remember that value of 1 plus iota whole square will be equal to 2 iota. How it is equal to 2 iota? Because we have studied in algebra about the formula of a plus b whole square. And what is a plus b whole square? It is a square plus b square plus 2ab, and here the a is replaced by 1 and b is replaced by iota. So I can say it is equal to 1 plus iota square plus 2 iota, and value of iota square equal to -1. So both cancelled and it is 2 iota. In the same way, I can say that 1 minus iota square, it will always be equal to -2 iota. So these are 2 basic things, and now I just have something very great thing for you to discuss over here. You know, in some previous year ND question paper, the value of under root iota is discussed. Okay, so there were 4 options and we have to calculate the value of under root iota. You know, we can see over here that 1 plus iota whole square equal to 2 iota. Can I say iota will be equal to 1 plus iota whole square upon 2? Okay, yeah, we can say that. So under root iota will be equal to 1 plus iota upon root 2 with plus minus. Okay, so it is the value of under root iota. Okay, and it has been asked previously in the question paper of NDA. Okay, in the same way, it is also asked that what is the value of under root minus iota. Okay, we can simplify that too. So we can say that minus iota is equal to 1 minus iota whole square upon 2. So under root minus iota will be equal to 1 minus iota upon root 2 plus minus. Okay, and in one of the question papers it is also mentioned to calculate that what is the value of under root iota plus under root minus iota. Okay, and you very well know that what is the value of under root iota? It is 1 plus iota by 2, and this is 1 minus iota by root 2. So we are simplifying this. It is 2 plus root iota, so it is equal to root 2. Okay, understand that? So these were three basic kind of things derivated just from a very simple kind of concept. Now if any student just wanted to save the time during the examination, he has to memorize these values directly. Okay, these are very common kind of things to remember or to have in the brain, within the brain. Okay, now we are moving forward, and we have discussed the values of 1 plus iota whole square and 1 minus iota whole square. Now we have to know few more things over here, and these are the direct algebraic kind of formulas. So always remember that. I'm saying that the value of 1 plus iota whole square into 1 minus iota whole square will always be equal to 2. You also have this, not whole square written mistakenly. I'm saying that 1 plus iota multiply 1 minus iota will be equal to 2. How equal to 2? We have discussed a plus b, a minus b. It is a square minus b square. So a is equal to 1 and b equal to minus iota. Okay, iota square, and iota square minus 1 minus will be plus. So it is 2. Okay, try to apply this. Okay, now always remember that if you are just going to see somewhere, that what is the value of 1 plus iota upon 1 minus iota. What is the value of 1 plus iota upon 1 minus iota? So always remember it will be equal to iota. Okay, how it is equal to iota? Actually we just have to multiply in numerator and denominator both places with the conjugate of this one, and we will discuss what is a conjugate. Okay, we will discuss that. In the same way we can say that 1 minus iota 1 plus iota will be equal to minus iota. This is also quite good thing to know. Okay, now I'm just gonna to place few kind of basic questions based on these all kind of things. Okay, so in previous year, one of the examinations of NDA, there was a kind of question that we have to get the value of 1 plus iota whole to the power 5 plus 1 minus iota whole to the power 5. We have to calculate the value of this particular term. So how can we calculate the value of this one? It is quite easy to calculate over here. What we will do over here, just to calculate this, the thing is quite easy. I just have to split the terms, as we have discussed 1 plus iota whole square. So I can write it like 1 plus iota whole square and again whole square. So 2 multiply 2, it is 4, and 1 plus iota is just remaining, plus again it is 1 minus iota square, again whole square, and I can write 1 minus iota again. Okay, so this is a kind of term we are writing over here. Now tell me students, can I say that 1 plus iota whole square is equal to 2 iota, and it will be equal to 2 iota whole square into 1 plus iota. Okay, now in the same way I can say that it will be equal to minus 2 iota whole square, and again it will be equal to minus 1 minus iota. Understand that? Now what do you think? We can say 2 iota whole square, it will be equal to 4 iota square, and it is 1 plus iota. It will be again equal to 4 iota square. This is 1 minus iota. Multiplying, you know what is the value of iota square? It is equal to minus 1. Minus 1 multiply 4, it will become minus 4, within bracket 1 plus iota, again minus 4, 1 minus iota. Now we are just multiplying minus 4 iota, minus 4 plus 4 iota. 4 iota cancel, so answer is minus 8. Okay, this is a good kind of question. Okay, based on the concept we recently discussed. Now I'm just gonna to write a question over here just for all of you, and you have to mention the answer of this particular question in the comment box. Okay, so do it. Okay, the question is that you just have to get the value of I'm saying 1 plus iota whole to the power 7 plus 1 minus iota whole to the power 7. This is a kind of homework for all of you. Okay, you have to drop the value of this particular question in comment box. Getting me? Now, we have discussed what is 1 plus iota his whole square, 1 minus iota, 1 plus iota, 1 minus iota. Okay, we have discussed all these kind of things. Okay, and one question over here, and you have one question in the homework. Now we are just going to move forward. So far we were just discussing about the imaginary term, means imaginary value iota. Okay, now we will start discussing about the entire complex number. As in the beginning we discussed that what is a complex number. Complex number is nothing but it is the combination of the real and the imaginary number. We discussed it. Okay, so I can say that always remember that a complex number is denoted by z. So I'm saying that z is equal to a plus iota b. Okay, so you are seeing here two terms. One is before plus, that is a. One is after plus, that is iota b. Always remember, the term which is written without iota, that is known as a real, okay, real term. Understand that? This is real part of complex number z. This is real part, and that this is, it will be denoted as REZ. I will say real part of z, it is equal to a, and this particular part means the coefficient of iota. Which one is the coefficient of iota? That is b. B is multiplied with iota, so coefficient of iota is b. This particular b is known as imaginary part. This is known as imaginary part and will be represented as imaginary part of z, it is equal to b. We can represent it in that way. Okay, now you have to have few kind of things in your brain, and these are very deep and simple kind of basic concepts. Okay, many times the examiner is just going to ask you that in which case a complex number will be purely real, or in which case a complex number can be purely imaginary, or in which case a complex number can be both purely real as well as purely imaginary. What are those situations? So firstly we are just going to discuss those kind of situations over here. Okay, so I'm saying, students, just listen to me carefully. I'm saying that the first concept says that if a real part of z is equal to 0, I'm saying that. Okay, so which one is the real part over here? A is the real part. I am placing a equal to 0, so you can see z will be equal to iota b. So in that case, if you are gonna to see anywhere real part of any complex number is equal to 0, in that case we can say then z will be purely imaginary. Okay, this is the first thing you should know about that. Okay, now I'm gonna to discuss over here the second very important kind of thing, and it says that if imaginary part of z is equal to 0, imaginary part of z is equal to 0, mean to say if b equal to 0, so it will be completely equal to 0, imaginary part will be equal to 0, and this portion will be equal to 0, and z will be equal to a. In that case we can say that then z will be purely real. Okay, and third thing you should have in your mind is that if both real part of z equal to 0 and imaginary part of z is equal to 0, in that case z will be purely real. Z will be purely real as well as purely imaginary, In this case z will be purely real and purely imaginary. Now you would have understood the things that there is only one number in the entire number system which is purely real as well as purely imaginary, that is 0. Okay, 0 is purely real as well as purely imaginary. 0 is working as both kind of numbers. Getting me or not? So this is a kind of thing you have to keep in your mind. Now we will discuss furthermore a few more kind of things over here related to the complex numbers. Okay. So what are we going to discuss over here? Listen to me. In previous classes or you have discussed about the coordinate geometry, and there is a Cartesian plane in which there is a real axis and another one is the there is one is x-axis and another is y-axis. So that same kind of plane can be used over here in the complex number, but over here that Cartesian plane is named as ergand plane, or you can say complex plane. Okay, so I'm drawing that plane over here. So these are the planes. Okay, and these both axes are just intersecting over here. This is known as the origin, you know, and in coordinate geometry it was known as x-axis. Here it will be known as real axis. It will be known as real axis, and this one will be known as the imaginary axis. Okay, imaginary axis. And you would have already known that this is origin of this, and right direction will be positive, this will be positive, this is negative, and this will be negative. Okay, so firstly you should know that how to identify the quadrant for any kind of the complex number. You know very well that I'm denoting z, suppose a equal to a plus iota b. If a and b both positive, it will be first. If a is negative, b is positive, it will be second. If both negative, third. Then if a is positive, b is negative, it will be fourth. We know all these kind of things, but listen to me very carefully. There is one more important thing. We have just to discuss the modulus of z. Okay, modulus of z. So always remember, what is the modulus of z? It will always be equal to under root of a square plus b square. Okay, under root of real part square plus imaginary part square. It will always be equal to this. Okay, and how to calculate this? We will dive deep little bit. Okay, you know, as I told you that each imaginary number can be represented in any of the quadrants based on the nature of the real and imaginary part. Okay, suppose I'm saying that a and b both are greater than 0, it means both are positive, and these can be denoted in first quadrant. So I'm saying that this is complex number z equal to a plus iota b. So firstly we will draw to a. Okay, a will be equal to parallel to real axis, and this is b. Okay, and we have to calculate this part. This is known as the modulus of z, and you know this is b and this is a. And what we have to do over here, just simplify the Pythagoras theorem. We will get that modulus z equal to under root a square plus b square. So modulus is nothing, it is the distance of that particular point from the origin. Understand that? Now quite simple things we are just going to start. We will discuss conjugate. Okay, conjugate. Okay, what is conjugate? Suppose z is a complex number over here with z equal to a plus iota b. So conjugate of z is nothing but it is a minus iota b. It is a minus iota b. Understand that? And how to calculate the conjugate of any kind of complex number? Just by changing the symbol of the imaginary part. If symbol before the imaginary part is positive, it will be negative. If the symbol over here is negative, it will be positive. This is conjugate z. Understand that? And one more thing, many times in the statement forms such kind of questions have been asked. Always remember, if any number is represented in the first quadrant, its conjugate will be in fourth. If number is represented in fourth, conjugate will be in first. In the same way, if any complex number is represented in second, its conjugate will be in third. If number is represented in third quadrant, its conjugate will be in first. So this is a simple kind of thing to have in mind. Okay, now we are just gonna to discuss few basic kind of things based on these two. Okay, we have mentioned over here that z is equal to a plus iota b, and we know that conjugate of z is equal to a minus iota b. We are just gonna to get some good better kind of results over here. Okay, and the results are number one. Suppose if we are gonna to add a complex number with its conjugate. Okay, we are just going to add these two. So if you are adding iota will be cancelled, it will be equal to 2a, means twice of real part of z. So always remember, the sum of a complex number with its conjugate will always be purely real. Understand that? Second, if you are just gonna to subtract a complex number with its conjugate, we are subtracting, so a will be cancelled, it will become 2 iota b. 2 iota b means 2 iota multiply imaginary part of z. So we can say that difference of two complex number will always be purely imaginary. You have to have this thing in your mind. Third thing, always remember that modulus of z will always be equal to modulus of z conjugate. Okay, modulus of these two is not going to make any difference over here. Okay, and the fourth is good to know. If you are just going to multiply both z with z conjugate, it will be equal to square of modulus z. Square of modulus z means is under root a square plus b square. Okay, you can say that. So these are the four basic kind of things to have in mind for the better performance to show in examination and to save the time over there. Okay, you would have understand that how did you get this z into z conjugate equal to modulus of z, because I told you modulus of each is equal and it is equal to under root a square plus b square. This is under root a square plus b square, so root will be cancelled, it will be this, and this is equal to square of modulus z. So these were the properties based on I would say conjugate. Okay, now I would like to tell you about inverse of a complex number. What is the inverse of the complex number? I'm just going to tell you about that. So if we are just going to discuss inverse of complex number, inverse of complex number. Okay, so suppose there is a complex number z and inverse of z will be equal to z to the power minus 1. Okay, inverse of z will be equal to z to the power minus 1. I am saying that inverse of z will be equal to z to the power minus 1, and it can be written as 1 upon z. Okay, now I am multiplying with the conjugate in both numerator and denominator, so I can write it as 1 multiply z conjugate upon z into z conjugate. So always remember, z inverse will always be equal to z conjugate upon square of modulus z. We discussed it on the previous slide. Okay, that z multiply z conjugate will be equal to modulus square of modulus z. Understand that? So you have to keep this particular kind of thing in your mind. Now whenever we are calculating inverse of any kind of complex number, we have to apply this formula directly. Okay, one day I was just going through a previous question paper of the NDA, and in that paper there was a statement. In the statement it was asked that in which case z inverse may be equal to z conjugate. Okay, he was saying that if somewhere it is mentioned that z inverse is equal to z conjugate, so in which condition it can be possible? So there is only one condition when it can be possible. If z inverse equal to z conjugate, then always remember, then modulus z must be equal to 1. Always have this thing in your mind. Okay, this is a kind of thing to remember. Okay, you can use it vice versa. If anywhere you found that modulus z is equal to 1, then always remember z inverse will be equal to z conjugate. That's simple. Okay, now four basic kind of concepts were developed using this particular term. I am writing 4 different kind of results, but those results are applicable only when modulus z is equal to 1. Always remember that if you see anywhere 1 plus z upon 1 plus z conjugate, so see what is added with 1 in the numerator. Z is added with 1 in numerator, so it will always be equal to Z. But what I told you, it is applicable only when modulus Z is equal to 1. If modulus Z is equal to 1, so always remember then 1 plus Z upon 1 plus Z conjugate will be equal to Z. Second is that if 1 minus Z upon 1 minus Z conjugate is asked to calculate, then it will be equal to minus Z. Third is that if you see 1 plus Z conjugate upon 1 plus Z, so it will be equal to Z conjugate. It will be equal to Z conjugate. Fourth is that if you are just gonna to see 1 minus Z conjugate upon 1 minus Z, so it will be equal to minus Z conjugate. Getting me? These are for basic kind of things to have on fingers to save the time in the question paper. Okay, now I am just going to put up a question over here from the previous year question paper, and it has been asked and discussed over there. He was saying that if he was saying directly that get the value of 1 plus cos theta plus iota sin theta upon 1 plus cos theta minus iota sin theta. We have to get the value of this. You know very well I can say that Z is equal to cos theta plus I sin theta. So Z conjugate will be cos theta minus I sin theta. We know this. And here modulus of Z will be equal to cos square theta plus sin square theta under root. And you know the value of this, so it is under root 1 means 1. So I can write it 1 plus Z upon 1 plus Z conjugate, so it is equal to Z. And Z, you know what is Z? Z is cos theta plus iota sin theta. So this is a question based on this particular concept from the previous year question paper. Understand that? So dear students, because of the shortage of the time, we are not able to take our class further. Okay, we will discuss remaining concepts in the next session, so stay tuned with me and just share my video with others, and please don't forget to subscribe the channel. Okay, we will meet in the next session. Thank you so much, thanks a lot for the support you are showing, and just promise to yourself that you are just going to learn the new things on daily basis and just going to improve everything. You are going to improve your maths, you are going to improve your English, you are going to improve your science, because you are on a journey. Okay, and you know, when you are on journey, it is just asking you to give to sacrifice all kind of the temptations you have in your life. Okay, so students, we will meet in the next session. Okay, thank you so much.